Welcome to my video lecture based on electric circuit theory, paper code PCE 301. It is included in the syllabus of knockout curriculum. Myself, Munmun Banerjee, Assistant Professor of Electrical Engineering Department, Dr. Sudhir Chandra Sur Institute of Technology and Sports Complex. Previously, it was known as Dr. Sudhir Chandra Sur Degree Engineering College under JIS Group. In my last lectures, I have already completed about introduction to signals and systems, and then I have covered on network theorems. Basic laws of circuit theory has been covered, and today we will highlight about introduction to graph theory. Basically, graph theory is a special version of network topology. Network theorems can be implemented using graph theory. That means, for solving a problem, if we are taking the help of graphs, then it will be very much easier for a person to solve those network problems. And how the graph theory can be implemented in case of circuit analysis, that we will show in this graph theory lectures. So let us start with introduction to graph theory part. In introduction part, we will learn that where we can apply the graph theory, what are the basic things of a graph, the circuit things, that means nodes, branches or mesh, these things can be also implemented using graph, and how this can be implemented, what are the things we can see in graphical approach, that we will see here. In electrical engineering, solution of network analysis problem involves finding the current through and voltage across different circuit elements. Different laws like Ohm's law, Kirchhoff's law, etc. have been postulated for simplifying the solution method. However, it is sometimes found that the algebraic equations written by different laws are not independent. On the other hand, the equations framed by the network topology methods are all independent. And network topology method has many other methods that can be listed as follows. First one, the graph theory or network topology deals with those properties of network which do not change with the changing shape of the network. That means the graph theory will be only applied to those networks which do not change in the shape of the network. Secondly, all the equations of KCL and KVL formed by the graph theory concept are independent equations. That means we can form the KCL KVL equations by help of graph theory, and that equations should be independent one. Thirdly, the graph theory concept cases the solution method for solving network with a large number of nodes and branches. With help of large number of node and branch, we can solve different problems using graph theory. That is another concept of graph theory. What is a graph? Graph of a network. Basically, a linear graph or simply a graph is defined as a collection of points called nodes and the line segments called branches. The nodes being joined together by the branches. See what I am saying here, that this is a network, and in this network these are the branches, this one, all are branches, and the junction points, these are basically nodes. So when we will draw the graph, first we will point out the nodes. Here we have 4 nodes A, B, C and D. So in the graph we have also 4 nodes A, B, C and D, and these nodes are joined with different branches. That means A and B is together joined with 4 ohm branches. So A and B is joined with 4. We have numbered it 4. Next, B and C is joined with 5 ohm branches. So it is numbered at 5. Then B and D joined with 2 ohm. Here A and D are joined by a voltage source. So this part we have taken 1. And between C and D it is joined with 3 ohms, so we have taken this 3. In that way we have put all the branches. And remember, whenever we will see a voltage source, the path will be definitely shorted or closed. But in case of voltage source, if there is current source, then definitely the path will be open circuited. The same concept applies of network currents, that is, voltage source internal resistance is near about 0, so the path will be shorted. When we are replacing it by its internal resistance, path is shorted. So similar way the path is shorted for a voltage source. This one. Now while drawing a graph of a network, the following rules to be noted. Point 1. That all the passive elements between the nodes are represented by lines. Secondly, the independent current sources and voltage sources are represented by their internal impedances. That is, current sources are by open circuit and voltage sources by short circuit. If they accompanied by passive elements like shunt admittance in a current source and a series impedance in a voltage source. Definitely these points we have to remember. First one is passive elements between the nodes. Definitely it will be represented by lines. That means what are the passive elements? Passive elements means resistance, capacitance, inductance. These are passive elements, and when we will represent it in graph, that will be represented by lines. Secondly, if it is independent current source, then it will be replaced by its internal resistance. That means it will be open circuit. And if we have to replace the voltage source, the path will be short circuit. So that means whenever we will put the voltage source, we will put just a straight line, and when we will talk about current source, the path will be just left open. In third point, we have to remember that if the sources are not accompanied by passive elements, an arbitrary impedance or admittance is assumed to accompany the source. And finally, we find the result by letting the impedance R tends to 0 or R tends to infinity, as the case may be for the current and voltage sources. That I have already told you that for current source, the internal impedance is basically infinite. So the path will be open circuit, because in high impedance part, current cannot flow, so the path will be definitely open. And whenever we are talking about voltage source, the path will be closed as the internal resistance is near about 0. Next, in order to discuss more involved method of circuit analysis, we must define a few basic terms necessary for clear, concise description of important circuit features. Let this is a circuit. In this circuit, we can see there is two voltage sources, V1 and V2. There is resistances R1, R2, R3, R4, R5, R6 and R7. That means we have 7 resistances connected in different branches, and we have one current source. So, as per the topology, the voltage source path will be shorted, all the resistance or branch path will be shorted, and the current source path will be open one. Okay. So, let us see what happens. We have to point out first all the nodes. What are the nodes? A node is a point in the circuit where 2 or more circuit elements are joined. Okay. So, here all the nodes A, B, C, I, G. Those are the nodes. Here A, B, C, D, E, F, G. These are the all nodes which has been highlighted here. Next we have to find which are the essential nodes. A node that joins 3 or more elements, that is basically the essential node. So for this case, the essential node is B, C, E and G. See, in these all nodes there are multiple branches are coming together to form the actual node. Next one, branch. A branch is a path that connects 2 nodes. That means the A and B, these are connected with some resistance, that is a node. That is a branch. For example, V1, R1, R2, R3, V2, R4, R5, R6, R7 and I. All are the branches. See, V1, V2, R1, R2, R3, R4, R5, R6 and I. All are the branches. Now we have to point out the essential branches. Those paths that connect essential node without passing through an essential node. Like CAB, this is our essential node CAB, then CDE, then CFG, PE, EG, PG and VD through I. These are the all essential branches. Okay. Next one, loop. A loop is a complete path, that is, it starts a selected node, traces a set of connected basis circuit elements and returns to the original starting node without passing through any intermediate node more than once. That means A, B, C, D, A and A, B, A, G, F, C, A. These are all loops. Next one is mesh. A mesh is a special type of loop. It does not contain any other loops within it. So, as per the diagram, we have also some meshes are there, that is A, B, E, D, C, A or C, D, E, G, F, C or G, B, G. Like that, there are different meshes are there. That means, see, this is a mesh, that is A, B, E, B, C. This is a mesh. This is another mesh, that is C, D, E, G, F. This is another mesh and this is another one. In that way, all the meshes are there. Now, next one is oriented graph. A graph whose branches are oriented is called directed or oriented graph. Next, rank of the graph. The rank of a graph is n minus 1, where n is the number of nodes or vertices in the graph. That means the rank will be the number of nodes minus 1 is the rank of the graph. Suppose we have 4 nodes. That means the rank will be 3. 4 minus 1, that is equals to 3. That will be the rank of the graph. Next, planar or non-planar graph. A graph is a planar if it can be drawn in a plane such that no 2 branches intersect at a point which is not a node. That means planar or non-planar graph. Okay. These are the points. So this is the planar graph, this one, and this is a non-planar graph. Okay. A graph is a planar if it can drawn in a place such that no two branches intersect at a point, which is not a node. So, see here, this is a non-planar graph and this is a planar graph. Okay. Next, subgraph. A subgraph is a subset of branches and nodes of a graph. The subgraph is said to be proper if it consists of strictly less than all the branches and nodes of the graph. So, what is subgraph? A subgraph is basically subset of branches and nodes of a graph. Okay, subset of the branches and nodes of the graph is known as subgraph. The subgraph is said to be proper if it consists of strictly less than all the branches and nodes of the graph. Okay. Next one is path. A path is a particular subgraph where only two branches are incident at every node except the internal node, and at the internal node only one branch is incident. In this graph, in figure 4.3, the branches are 2, 3, 4, together with all the four nodes A, B, C, D consist a path. A graph is connected if there exists a path between any pair of vertices. Otherwise, the graph is disconnected. Okay. Now, concept of tree. Basically, what is tree? Tree is basically combination of twig, limbs, core tree. Some properties are there for knowing the concept of tree. So, what is tree? Tree is basically combination of some twigs, limbs, core tree, like that. So, first of all, we know that what is twig. Okay. The twigs, basically the branches of tree are called twigs or tree branches. The number of branches or twigs in any selected tree is always one less than number of nodes. That is, 2 is equals to n minus 1, where n is the number of nodes of the graph. Okay. This is basically n minus 1, where n is the number of nodes of the graph. For this case, the twig is 4 minus 1, that is 3 twigs are there. Now, links and core tree. If a graph of a network is known and a particular tree is specified, the remaining branches are referred to as links. The collection of links are known as core tree. Okay. So, what is link? If a graph of a network is known and a particular tree is specified, the remaining branches are referred as links. Okay. And the collection of links are called core tree. So, see here. This is a graph and we have taken some dotted lines and some lines are just solid lines. So, see, the branches of a core tree may or may not be connected, whereas the branches of a tree are always connected. So, from the diagram, you must tell me that which branches are connected, which is tree and which are core tree. Tree must be connected and core tree may or may not be connected. Okay. So, first we summarize the thing. Number of nodes in a tree equals to n. Number of independent voltage, definitely it will be n minus 1. Number of tree branches should be n minus 1. And number of links will be b minus n minus 1, That means b minus n plus 1. That means number of links equals to total number of branches minus number of tree branches. Okay. Now the properties of the tree. In a tree, there exists one and only one path between any pair of nodes. Secondly, every connected graph has at least one tree. Third, a tree contains all the nodes of the graph. Fourthly, there is no closed path in a tree, hence the tree is circuitless, and the rank of the tree is n minus 1. That means these are all trees. The solid lines, this indicates the trees of the graph. Okay, this is the tree of the graph where there is no closed path. These are all trees, and the dotted line which combines the closed path, that is basically the links of the tree. Okay, links of the graph. Okay. Now next one is incidence matrix. The incidence matrix symbolically describes a network. It also facilitates the testing and identification of the independent variables. And the incidence matrix is a matrix which represents a graph uniquely. For a given graph with nodes n and b branches, the complete incidence matrix A is a rectangular matrix of order n into b, whose elements have the following values. Number of columns in A equals to number of branches equals to b. Secondly, number of rows in A equals to number of nodes equals to n. Aij equals to 1 if the branch J is associated with node I and oriented away from node I. Next, Aij equals to minus 1 if the branch J is associated with node I and oriented towards node I. Next, Aij equals to 0 if branch J is not associated with node I. This matrix tells us which branches are incident at which nodes and what are the orientation related to the nodes. Okay, so that is incidence matrix. Let us take an example. This is a graph. It has 1, 2, 3, 4, 5, 6 resistances. That means it has 6 branches are there, and there is A, B, C, D. 4 nodes are there. So this graph is looking like this. All the resistances are just put with a solid line, and the nodes are just put with a dotted line, and all the parts are closed like this. Now, as per the incidence matrix, we have to make a relationship between the nodes and branches. So here nodes are A, B, C, D and branches are 1, 2, 3, 4, 5, 6. So what is the relationship between node A and branch 1? Here the branch 1 is entering in node A. That means it will be minus. Then branch 2 has no relationship with node A, so it is 0. Then branch 3 has no relationship with node A, so it is again 0. But the branch 4, it is leaving from node A, so it will be plus 1. Remaining 5 and 6 branches have no relation with A, so it will be 0. Next node, that is node B. See, in node B, branch 4 and branch 5, branch 2, these 3 are connected, where branch 4 and branch 2 are entering and branch 5 is leaving. That means the branch which are entering, that will be minus sign. So in 2 and 4 we will put minus 1, and in 5 which is leaving, that will be plus 1. Next one is C. In C it will be 3, it will be minus 1, 5 it will be minus 1, and 6 will be definitely plus 1. And in D, from D, plus 1, 2, 3 and 6 is connected. From 1 it is leaving, from 2 it is leaving, from 3 it is leaving, that is all 3 are plus, and only 6 is entering, so 6 will be minus. So, this is the incidence matrix of the given figure 4.5. Now, if we want to make the reduced incidence matrix, we will just delete the entire row of the matrix. So, suppose this is a ABCD, 4 rows are there, so we will delete the node D. The remaining part of the matrix ABC, that will be our reduced incidence matrix. Okay. So, up to this is for introduction to graph. Graph theory is very interesting and important part for electrical engineering students. And by using help of the graph theory concept, we can draw any kind of network in form of graph, and all the calculations we can do using the graph, and it will be very simple and clear one. And incidence matrix can be drawn with the help of all the nodes and branches. Tree concept, four-tree concept, link, key, node, branches, all the concepts has been discussed here for understanding the basics of graph theory. And in graph theory, the most important part is incidence matrix and reduced incidence matrix. In this lecture, the part of incidence matrix and reduced incidence matrix has been discussed. I will refer the book of Abhijit Chakraborty for understanding purpose of graph theory, and you just practice different problems for solving incidence matrix and forming the reduced incidence matrix. And also try to develop and design some network problems and design those networks in incidence matrix form or reduced incidence matrix form. So that will help you to understand the graph theory concept. So after this is this much for today's class. Thank you all. Thank you all for listening my lecture. And in next math lecture, we will continue with the second part of graph theory, and we will discuss much more about the graph theory concepts in my next lecture also. So thank you all.